Hi Nitin, we are streaming live. You're the host.
Hi, sir. Okay, sir. Thank you. Okay. Good evening, everyone. We are going to start with the second session of organic. Previously, we have discussed about the IUPAC naming. We'll do a few questions of IUPAC naming if we get time today. What is the next topic which is there for you is isomerism. Okay. Now, isomerism is what? Those compounds which have same molecular formula, but they differ in their physical and chemical properties are called as isomer, and the phenomena is known as isomerism. See, now what is there? Basically, same molecular formula is there. Physical chemical properties you say, or you say structural formula, you can say. They are different in the terms of structural formula, or still one more is there. Maybe they are way of way of behaving towards the light is when way of behaving towards light or plane polarized light. We say it as PPL. It's different. Okay, so based on that, what is a molecular formula will stay same, but this few things will be different. Okay, the word or the term isomer was given by Berzelius. Berzelius, if you remember in the introduction class, we have studied Berzelius as a person who came up with the acetic acid, first organic compound which was discovered. The isomer was derived from a Greek word meaning equal or like part. Okay, so isomeros, so it's equal part. What is important for you now, when you're talking about isomerism, in that you are supposed to discuss about structural and stereo. For you, structural is there, stereo is not there, so you have to focus fully in stereo in structural isomerism part. Okay. So we'll go to the structural part. Going to the first one, the name first is structural formula. So basically what is that? Structural isomers are those which have same molecular formula, but they're different connectivity of atoms. That means structural will be different, arrangement of atoms can be different. Based on that things, we have differentiated structural isomer in few part. First one is chain isomerism. Now chain isomer, as we go to the formula, see butane is there C4H10. I can write butane as this, and I can write butane in this formation. Still, if you talk about here, the structural formula is different, but what is the molecular formula? I have 4 plus 10 carbon. I have 4 plus 10 hydrogen. Again, 4 carbon and 10 hydrogen. So this is basically the things, N-butane and isobutane. Okay, N-butane and isobutane is normal structures. I can draw the isomers in this fashion. I can't draw. Okay, before going to that, say first, if I'm talking about alkane, so alkane, the third one is this. The second one is C2H6. So obviously for one carbon, we can't do any arrangement. For methane, I can't do any arrangement. I can't change it. If I'm drawing the structure of ethane, so ethane is nothing but it will be drawn in this fashion, CH3 and CH3. Now I can't see, I can only say there is a structural difference when I say that there are name differences in that. But if there is no name differences, then we don't find the structural difference as well. Now say if I'm talking about chain isomerism, so what will be different? The chain will be different. Arrangement of carbon atoms in the main chain will be different. Now you can see here, if I'm trying to draw here, this thing will be the structure. So still I'm not, if I'm counting this as 1, this has 2, or this has 1, if this is 2, it will be still the name. I can't change, it will be ethane only. If I'm writing that in this fashion also, then also I have to write it as ethane only. So I can't draw an isomer when it is 2 carbon. For 3 carbon, if I'm trying, it will be like 1, 2, 3, or I can write it in this fashion, 1, 2, 3. In either way, if I'm counting it, it will be what, 1, 2, 3. If I'm counting this one, because I'm not jumping, so still this thing. So for the 3 carbon also, you don't have isomer. So isomer starts for an alkane from C4H10, that is butane. That is butane. Because here the name changes. You see, if I'm writing the straight chain here, this is normal butane, and I can write it in this fashion. Again, the things changes. Thing is changing in this way. So again, this becomes what? This is your isobutane. We can try for this as well. Like for, if I'm writing it for C5H12, that is pentane. So if 1 carbon, it is 1, 2, 3, 4, 5. This is normal pentane. I can write it in this fashion as well. 1 carbon here and this. Still this. I can write it in this fashion as well. You can see if I am to satisfy the bonds by giving hydrogen to it. So if I'm writing here, this will be CH3, this will be CH2, this will be CH2, this will be CH2, and this will be CH3. If I'm writing this one, this will be CH3, this will be CH3, this will be CH, this will be CH2, this will be CH3. And in this case, if I'm writing, this will be CH3, 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 and CH3. You can see here in this how many carbon are there? 1, 2, 3, 4, 5, 5, and then hydrogen is how much? 5, 7, 9, 12. In this also 3, 3, 3, 9, 9, 2, 11, and 1, 12. Carbon is 5. In this also 1, 2, 3, 4. So 3 times 4, 12 hydrogen and 4 carbon. So in all the cases, you see what is there. The formula remains same as C5H12. But if I'm writing the name for the first one, it will be what? Normal pentane. Writing the name for the second one, it will be which one? Second last CH3, isopentane. Writing the name for third one, second last 2 CH3 group, neopentane. So names are different. This time what I'm writing now, I'm writing the common name. If I'm writing the IUPAC names for this one, so first one IUPAC name will be which what? Pentane. There is no changes in them, so I'll just write it as pentane. For the second one, if I'm writing the IUPAC name, it will be what? On 2, I have methyl groups. I'll write 2 methyl, and the main chain contains what? 4 carbons, so butane. And for the third one, what will be the name? I'll write it as 2, 2 dimethyl, 2, 2 dimethyl propane. This is the normal structures. So basically what you can see, the length or the number of, you can see the number here in the main chain I had 5 carbon, in the main chain I have 4 carbon, in the main chain I have 3 carbon. So the number of carbon in the main chain is changing, and so that is known as your chain isomerism. In this also, this can also be said as position isomer because position of methyl is changing. For this too, we'll see that next. Okay, that is, this is the first one. I'm talking about chain isomer. Second is a position isomer. So position isomer says what? Same molecular formula, same length of the carbon, same functional group. Nothing is changing. Only the position changes. Example you see for position isomer. Now what is there? This is 1 chloropropane. This is 2-chloropropane. Everything is same here. See, formula if I'm writing for this will be what? C3H7Cl. Here also if I'm writing C3H7Cl. Formula is same. Position of what is changing? Position of 1 chloro is changing. Here position 2 chloro is changing. Here also now I have alcoholic group OH. So at 1 carbon, at 2 carbon, position is changing. Position is changing. Here also propylamine on N-propyl and isopropyl. This they have given you common name, but still in the common name terms of just writing the name for this will be what? Propanamide. If I'm writing the name for this will be what? Propanamide. Propanamide. And if I'm writing the name, it will be what? Propane 2-amide. Position is changing. Again here butene 2-butene. Position of what is changing? Position of double bond is changing. But still I have double bonds only. So the functional group is not changing, but the position of the double bond is changing. Here you see orthoxylene, metaxylene, paraxylene. If I'm writing the name for this, I'll write what? 1,2 dimethyl benzene. 1, 1, 2, 3. So 1, 3 dimethylxylene. Here again what? 1, 4. If I'm writing the name for this one, it will be what? 1, 2 dimethyl benzene. If I'm writing for this, it will be what? 1, 3. For this, if I'm writing 1, 2, 3, 4. So for this one, the name will be what? 1, 4 dimethyl benzene. So what is it? Okay. Next, we have ring chain isomer. Such isomerism arises because of the difference of carbon chain or ring. Now you see here, this is cyclopropane and this is I have cyclopropene. If I'm drawing cyclopropane, basically, so I have 3 carbons here. To satisfy 4-4 bond of each carbon, I need 2 hydrogens over here. I need 2 hydrogens over here. I need 2 hydrogens over here. Formula for this will be what? C3H6. Now here you see what is the C3H6. But what is changing? With the same formula, one is ring, another is aliphatic compound. When this is open chain, we say it as aliphatic compound. So one is aliphatic open chain and one is closed chain. So this kind of things are known as ring chain isomerism. Cyclobutane, you see a cyclobutane here is a ring. And this is what? This is an aliphatic compound. This is butene. So this is known as ring chain isomerism. Okay. Next we have in structural is functional group isomerism. Everything will stay same, only functional group will change. Okay. So you can see here, if I'm writing here formula, this will be what? C2H6O. You write for this C2H6O. But the group is what? Here alcohol is there, ether is there. Okay. You see here again, your acid is there. And this one acid is there. When I'm talking about this is propanoic acid, and here this is acetate. So ester group and acid group. This is 1 degree amine, this is 2 degree amine, this is 3 degree amine. So what is changing again here? So this is degrees are changing, right? 1 degree, 2 degree, 3 degree amine. Okay. So you see N, NH, NH2. This functional group is changing. This all is functional group. This is amine, this is imine, and this is N group. Now alkynes and alkadienes. Alkadienes is what? Basically I have 2 double bonds over here. So alkyne is what? 1 triple bond, and this is what? Alkadienes means what? 2 double bonds. This is what? Triple bond. So alkynes and alkadienes. These are examples. Functional group isomerisms examples you remember. Pairs you are getting into the form of alcohol ester, acid ester. Sorry, alcohol ether, acid ester, 1 degree, 2 degree, 3 degree amines, alkynes and alkadienes. Because in the questions you will get it directly, you will not have that much time that you keep on checking each and every one. Okay. This is important. Metamers. Now metamers arises when this type of isomer arises due to unequal distribution of alkyl substituents around a polyvinyl functional group. Okay. For example, you have this have ether. So ether, what is their possibility? On this side I have methyl and on this side I have ethyl. Ketone is there. In case of ketone, again, how it will be there? In ketone, I maybe on this side I have C2H5 and on this side I have CS3. So where I have a possibility where we can have different kind of alkyl groups attached to them. So for those things, what we try to do, we try to incorporate that, and this is said as metamers. Okay, examples of metamers are that you can see the examples here. This is 2-pentanone and this is 3-pentanone. Okay, now what is changing here? You can see that after this oxygen, here one side I have one that is methyl group, and this is what? This is propyl group. Again, here you can see what is there. Here I have ethyl and ethyl. Still the molecular formula is same, but here the distribution is different and the name is changing. So this you can say it as this is a position isomer as well. But when I have to choose between metamer and position, we have to give the priority to metamer. First will be metamer only. If I have to give priority metamers, if I have position and metamers, both will be there in the option. So I'm supposed to tick metamers. So metamers has given priority over them. Now the next few examples of metamers, you have diethyl ether and methyl propyl ether, diethylamine and methyl propylamine. This is unequal distributions. There's nothing, this is unequal where you find unequal distribution, they'll have this thing. Okay, so that is your isomerism basics, and that much is enough for you for the questions being asked. For IUPAC, whatever we have discussed, we are going to do the questions now. In this slide only, at the end of the slides we have the questions related to IUPAC. 1, 2, 3 questions. I think few questions are there with isomerism as well. Okay, so for next is what method of preparation of methane you say, or in basic we are just trying to say alkane, but alkane we have this, instead of studying everything about alkane, we are studying it for ethane. So what is that laboratory preparation for methane? What we do is we heat the mixture of, this is what, this is sodium acetate, because I have two, you can see here, this is acetate group, CS3CO. In the last I have given you valency thing. If we go there and see, this is acetate group, CS3CO minus Na. Na is sodium. So Na is reacting with soda lime to form sodium carbonate and giving methane. The ratio will be 1:2. If this is 1, this will be 2. That ratio it is taking. When I'm talking about general methods, it is CS3I. This is methyl iodide. If I'm talking about this thing, this is methyl iodide. Okay, but the name is written anyway there. In presence of hydrogen, catalytic reduction I'm doing gives you CH4HI. This is what? Hydrogen iodide. By the hydrolysis of aluminum carbide, most important, most questions. This is aluminum carbide. You need to know the balance equation for this. Aluminum carbide plus 12H2O gives you 3 moles of CH4, and this is what? This is aluminum hydroxide. This is aluminum hydroxide. General methods. Next, we have few physical properties of methane. Methane is a colorless and odorless and non-poisonous gas. Melting point, this is degree Celsius, degree Celsius. Okay. Now next thing is chemical properties of methane. Combustion reaction, important. See, if I'm talking about combustion reaction for any particular hydrocarbon, we can write it in this form. That's CX plus HY plus X plus Y by 4 O2 will give me what? XCO2 plus Y by 2 H2O. Based on that, we can balance any of the reactions related to hydrocarbon. Hydrocarbon undergoes any combustion reaction, any hydrocarbon. If you're talking about alkane, alkene, alkyne, any of them will undergo and will form the things in this. Any particular hydrocarbon which is going proper combustion or oxidation reaction, they'll give you product as CO2 and H2O. If there is incomplete combustion, that will give you product as CO and H2O. Okay, so this is what is oxidation. Now, when I'm talking about halogenation, basically what happens is halogenation, the word only suggests halogens are going to get attached to the alkanes. So what we basically do is, for example, they have taken you CH4. So CH4 is there and they're reacting with Cl2. How this basically happens is, this is what is your CH4. This is your CH4 and this is basically what? Cl2. So what they do is, here what happens is, here they have a homolytic fission, and they'll take their electron, and the Cl and Cl will take their one electron. They'll become, in this situation, which is known as free radical. Free radical. This free radical will, what it will do is, now after this, what this free radical will do, this particular H will go out as H plus. Okay, it will come out, and this particular H will go and combine with one Cl, and one Cl will come and substitute this point, so which will be written as CH3Cl plus HCl will come out. So this is known as what? CH3 is known as what? Chloromethane. Like that only it will undergo till all the hydrogens are substituted by chlorine. So you can see here, first it goes to CH3Cl, then CH2Cl, then CHCl. So it will go to CCl4, CHCl3, this particular thing, carbon tetrachloride, CHCl3 is chloroform. In this place, if you have CHI3, that is iodoform. This is CH2Cl dichloromethane. So this process is what the condition here is, what it is basically done in the process of H nu. We have to give in the presence of sunlight. In presence of sunlight, any reaction will be showing you free radical mechanism. Any reaction will show you free radical mechanism, and it is being conducted in the presence of sunlight. Okay. Next is ethene. Ethene is also known as ethylene. Okay. Previously it was known as ethylene, common name. Now it is, the IUPAC name is ethene only because it have double bond present in that. The formula for this is CH2 double bond CH2. Okay. It is the first unsaturated aliphatic hydrocarbon series. The first thing, because we have double bond and triple bond. In the double bond also, one number carbon doesn't show any kind of alkene formation, because for the double bond you need the double bond, but you can't form a double bond between hydrogen and carbon. To form a double bond you need two carbons at least. Okay. So in laboratory, how it is prepared, it's by dehydration of ethanol. Dehydration basically means removal of H2. To remove H2, we are using H2SO4 as a dehydrating agent here. H2SO4 is used here as dehydrating agent. Dehydrating agents are those agents which take out dehydrating agent, which take out water. So at 170 degrees Celsius, from when I'm talking about ethyl, it's dehydrating agent, it will form ethene, H2 will come out. Okay, H2 will come out in this. Next, cracking or dehydrogenation. When alkenes of higher molecular weight are heated at higher temperature, the molecules break into alkenes and alkenes of lower molecular weight. Okay, so when you're heating ethane, it will break down and it will form CH2. We are using catalyst as SiO2 and Al2O3. Okay, hydrogen is coming out here. Dehydrogenation is written. No, dehydrogenation basically means removal of hydrogen. So removal of water was dehydration. Removal of hydrogen is dehydrogenation. So ethene, you can you have these things which is used, you're using for forming of ethene. Physical properties: ethene is colorless gas. Ethene poses pleasant odor at STP. STP stands for standard temperature and pressure. Ethene is completely soluble in organic solvents and slightly soluble in water. Because ethene polarity is there, it is very less, and that is there because of the presence of pi electron. Pi electrons are normally reactive, so because of that it have a slight polarity. It is lighter than air. Boiling point of ethene is -102 and melting point is -169. Okay, it has an anesthetic effect on inhalation. If you try to inhale it, you try to smell it, it might lead to the fainting situation. When it comes to chemical properties, again, combustion, ethene, it's a hydrocarbon, it will form 2 CO2 and 2 H2O. It will release heat. Releasing heat, things are what? Exothermic reaction. All the combustion reaction are also exothermic reaction. Or you're talking about all the oxidation reaction, that is also a exothermic reaction. When I'm talking about the reactivity, ethene is more reactive than ethane and methane. Clearly, why ethene is more reactive? Because the presence of pi electrons. In case of ethane and methane, we don't have any pi electrons. So because of this, when it have a, the thing is what, like say, if I have ethene, I'll write it ethene here. So this is what is ethene. This is what is ethene. So you can see here what is the situation here is here we can add something by breaking this pi bond. But in case of methane, ethane, you have to use this is methane. In case of methane, we can only have substitution reaction because all the 4 bonds of carbon are occupied. So all the 4 carbons are occupied. So obviously it will lead to what? It can only have which kind of reaction? It can only have your excuse me, it can only have substitution reaction. But when I'm talking about double bond or triple bond, we have chances of forming addition reactions. Addition products will be formed. So addition reaction is what? It's a chemical reaction. If 2 substances combine to form a third substance, in general, unsaturated hydrocarbons like alkenes, alkynes prefers to undergo addition reaction. Okay, so you'll find out addition reactions mostly in the case of. This is first addition reaction, addition of hydrogen to ethene. So we are doing what? You have catalytic hydrogenation in presence of liquid. You can use palladium also. You can use platinum as well. Anything can be used. But nickel at 300 degrees Celsius, it will what? It will break this bond because of this bond availability. One hydrogen will come and combine to this. Other hydrogen will come and combine to this, which will lead to the formation of ethene. This is basic your addition reaction. Again, we can do this for halogens, adding halogens. Okay, so your addition of chlorine. So you're trying to add chlorine. You add chlorine, you get 1,2-dichloroethene. Okay. We are using CCl4 there. Okay, now it can undergo polymerization reaction. If I'm taking n mole of ethene, we are doing polymerization of it. It will go to polyethene. Again, the polymer ethene is formed at very high temperature and pressure. But polyethylene is not that much useful because it's non-biodegradable if it is lesser than 40 microns. Okay, next is acetylene. Acetylene is nothing but ethyne. As this is common, it's nothing but ethyne. So in large scale, calcium carbide is made to react with water to prepare this. So prepare that what this is calcium carbonate, which is dissociated in presence of heat to form calcium oxide and carbon dioxide. This calcium oxide is reacted with 3 moles of coke to form calcium carbide. Carbon monoxide is taken out here. And this calcium carbide is reacted, or hydrolysis of this is being done. Hydrolysis of calcium carbide is being done to form what? This is forming what? Calcium hydroxide. Calcium hydroxide is also known as what? You should remember that calcium hydroxide is also known as what? Slaked lime. And this is what? This is C2H2. This is nothing but ethyne. This is how we have first preparation of ethyne. Next, dihalides are obtained from corresponding alkenes by addition of halogen. We're trying to add hydrogen here. We can see that I'm taking here what? This is CH2, CH2Br. Basically, what we took is we took CHT, CH2, and this is Br, and this is also Br. When we are trying to react this one with KOH. When I'm trying to react this with KOH, what happens? There will be removal of KBr. One K will go with one Br, and say hydrogen on this. One hydrogen comes on this side, and one hydrogen with this O, it comes out. I get minus of KBr. KBr comes out, and minus of H2O we get. After this, this gives me first alkene. And alkene again, when I'm trying to react it with Na plus NH2, Na plus NH2 minus, basically sodium amide or soda amide, we say it will give you ethyne. Okay. Give you ethyne. Now, Next is haloform, very important. So anything can come in here. I3, normally we take I3 here. Silver, this is again X3HC. Heat we are doing. We are trying to get it in the powder form. This is what is ethyne. This is AgX. Cold-based electrolytic method, important. We are taking potassium salt, or we can say it as what? This can be written as what? This particular is basically potassium acetate. So from this I'm trying to, this is known as pot fumarate or maleate. This total is written as that. Pot fumarate or maleate. Electrolysis of this we are doing. At anode we get ethyne. Okay, and at cathode we are getting hydrogen. Basically, you don't have to remember this. At cathode we are getting hydrogen, and at anode we are getting ethyne, according to coal-based electrolytic method. Okay. Now I'm talking about ethyl halides. Ethyl halide is basically what? It's an alkyl, right? It's an alkyl halide. If I'm talking about the formula of ethyl halide, what will be the formula for ethyl halide? Okay, ethyl halide formula will be, ethyl halide formula will be what? It can be CH2H5 is ethyl and X. This is what is ethyl halide. So when talking about ethyl halide, we have few preparation method of ethyl halide. So first preparation is what? If I'm trying to react 3 moles of 3 alcohol, this is which alcohol? This is nothing but ethanol in presence of PI3. This gives me C2H5I plus H3BO H3PO3, 3 moles of this. This is what is the first reaction for the preparation of ethyl halide. Also, ethyl halide can be prepared for from this one, that is C2H5Br plus NaI, which again substitutes, they can change the position, the halides. So this will give you C2H5 plus NaBr. Then number 3, C2H6 alkane in presence of Br2, bromination reaction H nu in presence of sunlight, it will give you C2H5Br, and there will be a extra product which is known as HBr. More if you want to write, there's one more, this is actually important, C2H5 COOAG. Okay, this is silver salt of ethyl acetate. Okay, silver salt of ethyl acetate. This in is, okay, this in presence of Br2. So we are trying to react it with Br2. It will give you C2H5Br, C2H5Br plus CO2 plus AgBr. Okay. So we have some names for this reaction. This is what? This is basically preparation of from alcohol. So what is this? This is ethanol. This is the laboratory preparation, ethanol. When I'm talking about this reaction, this is known as basically halogen exchange is happening here. So you can say it as halogen exchange method, or this is also known as what? Finkelstein reaction. Finkelstein reaction. Finkelstein reaction. Now, when I'm talking about C2H6, this is an alkane in presence of Br2 H nu, it forms C2H5. This is ethyl bromide. Okay, and I'm talking about this thing. This is C2H5, and this is silver salt, and this reaction is known as what? So you can write the name of this. We just said halogenation because it is happening in presence of bromine. I can say the reaction as bromination, and this is another name reaction, which is Hunts-Dicker reaction. Hunts-Dicker reaction. This is basically, we are talking about ethyl iodide, or so ethyl halide. Basically, I'm talking about ethyl iodide in this case. Ethyl, suppose we have just discussed what we have discussed here is ethyl iodide. Okay, Now let's come back to benzene. So we have to study structure of benzene. Structure of benzene, I should know. We draw the structure of benzene in this form, which is alternate double bond, or we write this using the resonance structure will be like this, where we assume it to be everywhere, all throughout the ring it is distributed. Who had given this structure is now given by Kekules. There were problem with this, but it was accepted after benzene thing. Okay, Kekule have given this. So we have laboratory method preparation of benzene. We have taken sodium benzoate. You can see this. This is sodium, and because it's benzene and OH, so sodium benzoate, soda lime NaOH. Okay, this is soda lime. You are heating it, benzene gets, and this is what? This is sodium carbonate. This is laboratory method. Okay. Next is you need to know laboratory method only if you don't have time, but for other from benzene derivatives, how you can do this is phenol zinc. Zinc will be there in the form of dust. Okay, zinc dust method. So we have phenol. Phenol we are trying to reduce basically using zinc, and when we distill it, we get benzene, and zinc oxide comes out. Okay. From chlorobenzene, this is chlorobenzene. Chlorobenzene, you're basically trying to reduce two H's here. It is reduced. We have taken what nickel aluminum alloy in presence of NaOH. This gives you benzene. HCl is the extra product. Okay. Next, by first preparing Grignard reagent. Grignard reagent is nothing but RMGX. This is what is Grignard reagent, where R is alkyl group. Where R is alkyl group and X is what? Halide. So RMGX. So to prepare RMGX, we have taken chlorobenzene in presence of Mg and triether. So we get it as RMGX. We do hydrolysis of that to get benzene. Okay, to do hydrolysis of that to get benzene. Okay, next is the naming things are coming here now. Next is your benzene sulfonic acid in presence of steam. We have taken water as a steam as a temperature of what? At a temperature of 150 to 200 degrees Celsius. And we have taken HCl. HCl basically means what? It has been taken in acidic medium. In acidic medium, and so it gives you what? Benzene, and the product comes out as H2SO4. So you can see that we are using HCl, and the product H2SO4 is recovered. Okay, from benzene diazonium chloride. These are basically diazonium salts. Okay, so this is nothing but this is this. This is something like this. This we have N2 plus and Cl minus charge on that. We are trying to reduce it in presence of essential stannous chloride. Okay, NaOH. This will give you what? Benzene. Product will be further product will be N2 and HCl. Okay, from acetylene again we have 3 moles of acetylene taken here. This is we take 3 mole of acetylene or ethine, 3 moles of ethylene in presence of red hot tube. In the red hot tube, where the temperature is some 1500 to 2000 degrees Celsius, it gives you a product as benzene. Basically here this is an example in acetylene. What happens here? Cyclic polymerization. You can write polymerization, you can say cyclic polymerization, either way it is right. One more polymerization reaction where we have seen in case of ethylene. Okay, very important. Aromatization, basically we are trying to find out a ring. Why we have ring here? This is an N-hexane aliphatic 1 2 3 4 5 6. We have H3 over here. We have H3 over here. This is CH2, 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 CH2. This is a straight chain compound or aliphatic compound. We can say it as this is a straight chain compound or aliphatic compound. In presence of chromium oxide and aluminum oxide at 500 degrees Celsius and a high temperature, it can be converted to benzene. Benzene basically means what? From straight chain you are getting what? Ring. So that's why this reaction is known as aromatization. Hydrogen comes out of it. Physical properties of benzene. Benzene is a colorless, mobile and volatile liquid. Its boiling point is 80 degrees Celsius and freezing point is 5.5 degrees Celsius. It have a characteristic odor. It is highly inflammable and burns with sooty flame. Sooty means blackish flame. Okay. It's lighter than water. Specific gravity is 20 degrees Celsius is 0.8788. It is immiscible with water, but miscible with organic solvents such as alcohol and ether. Immiscible, it doesn't mix. It mixes only with organic solvents such as alcohol and ether. Number E, benzene itself is a good solvent. Fats, resins, rubber, etc. dissolve in it. So benzene itself is what? Benzene itself is an organic solvent actually. Okay. It's a non-polar compound and its dipole moment is 0. Dipole moment is what? If I'm trying to define dipole moment in physics, what dipole moment you have studied is you have a two charge which is separated by a small distance of 2L. So dipole moment is given as the product of either of magnitude of either of charge into the distance between them. Okay. So in chemistry also we have polar compound which we are supposed to study, which depends on that how, like say if I'm talking about water. So water structure, if you talk water structure is like this. Okay. Now because lone pairs are present here, so we say them as this is a polar compound, because if lone pair is not present, we say it is non-polar compound. But when we're talking about benzene, their effect from have to take the resultant from everywhere. You can see the resultant of this will cancel the resultant of this. So anyway, finally dipole moment is 0. This is non-polar, so that's why we write benzene as what? Benzene is a non-polar solvent. It's a non-polar solvent, so it gets dissolved also. If you're getting dissolved in something also, that also has to be that also is supposed to be what? Non-polar. And if you're dissolving it in something, that is also supposed to be non-polar. It's an extremely poisonous substance. Inhalation of vapors or absorption through skin has a toxic effect. It is bad. Okay. Now, due to presence of p electrons clouds above and below plane benzene ring, the ring serves as a source of electrons and is easily attacked by electrophiles. Basically, what happens now when you're talking about benzene, all the carbons in benzene is sp2 hybridized. All the carbons in benzene is sp2 hybridized. Because of all this also, it's because you can see throughout the ring you have double bond. So this double bond character also makes it a very more, because obviously when something have pi electron, it is reactive. So for benzene you have addition reactions. So addition reaction, benzene again same in presence 3H2 nickel, it is formed cyclohexane. Okay, addition of halogen, again addition of halogen is possible in benzene. Okay, addition of ozone, we are trying to add ozone here. This particular thing is known as ozonolysis. Ozonolysis is important reaction. What we do is we take benzene and we are taking 3 mole of O2 after, and here we have taken hydrolysis. We are saying this is, we have two kind of ozonolysis. One is reductive, other is oxidative. This we are doing reductive ozonolysis, and that leads to the formation of glycol and 3H2O2. So this is what is addition of ozone. This reaction is known as ozonolysis. Okay, so further it does what? It does nucleophilic reactions. Nucleophilic reaction is what? What is a nucleophile? We have two kind of attacking reagent. One is nucleophile, other one is electrophile. So electrophile, basically when I'm talking about nucleophiles are those 6 which are electron which tries to go for negative positive charge. They want positive charge. And electrophiles are something which try to go for negative charge, being positive charge species, and this is negative charge species because of that. So we have substitution reaction also in two ways. It can be nucleophilic substitution, it can be electrophilic substitution. When a nucleophile substitutes a ring, it is known as nucleophilic substitution reaction. When an electrophile substitutes, that is known as electrophile substitution reaction. So this is electrophile substitution reaction. Then again, as the hydrocarbon same, this also undergoes oxidation reaction. Oxidation reaction again is exothermic. When vapors of benzene and air are passed over vanadium pentoxide 450 degree and to 500 degrees Celsius, maleic anhydride is obtained. Formula remember, Okay, in reduction also it has 12 HI. You try to react, it will give you cyclohexane and methyl cyclopentane. Okay, methyl cyclopentane. Okay, this is basic reactions of all this. You have to remember this. You can see that there's not much to do with this. We have to remember the things and then we have to do the questions. What we'll do is try to revise organic now. So what we have done. Okay, so we have questions here starting with IUPAC. So you can start doing the question. We'll do the questions. And if time is there, we'll go for more further. So go ahead, start doing the questions. Let's do the question. Okay, we have answers. Pratik Tapra 1A. Let's see. Pratik says 1A. Other people answers. Sunil Bhandari also says A. Avinash also says A. Radna says B. Okay. Komal says A. Okay, let's see. Now, when we are trying to write according to the priority order, I'll write this as 1. This will be 2. This will be position 3. This will be 4. This will be 5. And this will be 6. I can't go ulta like this 1, 2, 3, 4, 5, 6, 7. Or 1 like from here 1, 2, 3, 4, 5, 6. Ulta because the substituent will go get more number. If I'm going in this way, substituent in getting the numbers are 1, 2, 4, and 5. If I'm going in this way, it will get 3, 4, and 6. Clear? If I'm going ulta way, here if I'm going, the substituents are coming at which position? At 2, 4, and 5. If I'm going ulta, it will be 1, 2, 3. It will be at 3, 4, and 6. You can see the numbers here. This is 11, and this becomes 7, 6, 13. So we have to go with this order. I'm going with this order. So what will be the name? What we have is at 5th group, I have amino group at 5th. Then what we have at 4, we have at 4 we have this, and at this place I'll have carbon. So at 4 I have what? At 4 I have hydroxy methyl. Again at 2 we have nitro group. After that is benzene ring with benzaldehyde. So the option should be C. Please check through the reaction, through the naming of IUPAC, you will be able to revise everything. For you, IUPAC nomenclature is very, very important. And that's also most of aromatic. I have taken the questions based on aromatic as well as a mixture of aromatic and aliphatic questions I expect can come. Not taking the easy things, but we are trying to revise the concept here to the questions. Okay, let's start with the question number. It's good that you all are trying, you'll learn definitely. So we'll just not Try to learn special. I think okay. Second one we have the answer. Second one is B. Ritik says second one is B. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. And last box is 2B. 1, 2, 3, 4, 4 bromo. Yeah, okay. So only one is there in 4 bromo. Right. If people not understood, you can see this here. If I'm going, it will be 1, 2, 3, 4. So substituent will be which one? At 2 and at 4. If I'm coming ulta way, it will be 1, 2, 3 and 4, 5. So 3 and 5. 2, 4 is 6, 3, 5 is 8. Anyway, you can compare the first position only. So 2, 3. This is what I will go with. Okay, so Avinash Ritik, right? So is this. Go to the third one. What is the answer for the third one? The third answer from Ritik. Avinash is okay. We have contradicting answer A and C. Avinash C, Ritik A, C. So priority order, numbering what is important. So numbering here 1, 2, 3, 4, 5, and 6. CHO, carbon of CHO can be counted. Okay. So now if I'm writing this, I can write now name as what? At 2, comma, at 2 and at 5 I have methyl. So 2, comma 5 dimethyl. After that, what I have? I have at, so I have at 6. At 6, I can't find that. There's no answer is what is XML. So XML is not possible. Enoic acid and enoic acid. Right. Okay. Oh, I missed that. So answer is C. Okay. Again, I have to go to back to fourth slide. I don't want to go. So answer is C basically. Okay. Try fourth. Answer is C, Avinash, right? Ritik, answer is C. Fourth answer is given by Avinash B. Rohan have given answer as B. Okay, Rohan gave answer as D, B. Let's check. So if I'm trying to do numbering for this, I try to do numbering for this as. So if you're having problem, you can just split it and write. That also is fine. Trying to write number wise. Okay, if I'm trying to do numbering, I'll do it as one, two, and multiple ones I can take. Right? So I can write it from this side. 1, 2, 3, 4, 5, 6, 7. So I'm doing that. So I have what to do, but 3 and 5 dimethyl. On fourth, I have propyl. 1, 2, 3. So propyl. At 1E. Yeah, okay. D is right. Avinash said B. Avinash, we have to end always the name with I. When we have double bond and triple bond, the priority, the name will get over with triple bond, but we have, as priority wise, the number should be, the lowest number should be given to the double bond. So in that sense, if you see 1E is double bond is given the lesser number, and the number is ending with triple bond. So E9 always it will end with A9. So D is the right answer. Next one, please try fifth one. Fifth one, Avinash gave the answer. Ritik, okay, contradicting answers. So we have answer as Rohan have B, we have C, C. Omal says C. So C, C, B, and C. Okay, so 3 C's and 1 B. Let's see. Okay, so when I'm going to the priority order, so here all are basically, so what I'll do is I'll give priority in the terms of methyl. So this both are always used as prefix. So I'll give the priority to this. So 1, 2, 3, 4, 5, 6. So based on this, if I'm trying to write the name, it will be what? 2 chloro, 4 nitro, 2 chloro, 1 methyl, then M after that M. So we have what? 2 chloro, 1 methyl, 1 4 nitrobenzene. 2, correct, 2 chloro, 1 methyl, 4. Okay, so answer is B. So Rohan answer is B. Yeah. People have given C as answer. 3 chloro. How 3? They're going it in this way. 1, 2, 3, 4. Okay. This all are prefix groups. Okay. Nitro is also prefix. Chloro is also prefix. Methyl have to be given priority when I have anything. And if say if I have double bond, triple bond, all that stuff, what we go in that accordance. And same accordance, if you have an alkyl group, if I have all the prefixes and I have alkyl group attached to it, alkyl will be given priority. Okay. This will be given priority. Try 6 1 you're doing, right? Yes. 6 6 answers we have. C, C, Komal gave B. C, 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 C. I'm trying to do numbering. It will be what? 1, 2, 5. So 3 hydroxy, 3 hydroxy, 3 hydroxy, 4 methane. And the third one is the answer. Yeah, Rohan. Rohan answer is 4 C's, 6 4 C's. Okay, C is the correct answer. Okay, next 7th one. We have options here. Just draw the structure over here. Structure is something like this. This is like what structure is. Seventh answers now. This is a structure. I have drawn the structure. Rohan, this is what is a structure. You don't like my handwriting, man. This is what is a structure. This is double bond over here. Like this, we have thing. We have this and this. Like this, it goes. We have this, this. So what is the structure? I have drawn the structure. So Neil have answers. Ritik have answers. So Neil answer is. Can see two contradicting answers we are getting. So 7 answer. Okay, you want the substituent? The substitute Br is here. This is Br. Double bond should be given priority. So 1, 2, 3, 4. Somewhere on left ascent. I think the confusion regarding this is coming. This is coming. So 1 minute. I'd draw the structure. Also, Rohan also have the answer D. Okay, fine. Go for the 8th one. Answer is D. Go for the 8th one. 8th one. Ritik have answer. 8 1 is D. 8D. 1, 2, 3, 4, 5, 6. Okay, so 4 ethyl. Okay, yeah, D is the answer. Avinash also got, Sunil also got. Go for the ninth one. Ninth also Ritik have answer as B. Ninth answer B. Rohan, ma'am, 8D or A? Ma'am. I sound like ma'am. 8th one is D. It's okay, Rohan. It's okay. Answer for 8th is D. Ninth answer is, who gave ninth answers? Avinash is saying C. Ninth Ritik said B. Sunil said B. Avinash is saying C. Okay, so contradicting answers. Let's go with that. So ninth one, if I am doing the numbering, I'll start it from here. So 1, 2, 3, 4, 5, and 6. So on 1 we have dimethyl, on 2 we have ethyl. So 2 ethyl and alphabetical order will go. So 2 methyl. So 9 answer will be B. Okay, on 2 ethyl, 1 dimethyl, cyclohexane. Answer is B. C, 1 ethyl is not there. On the numbering will start from here because you have to just see the number of substituent. If you're taking the number, in this situation, I'll get it as 1 plus 1 plus 2. With your thing, if I'm trying to go, it will be what? Now, if I'm talking about C, so 1 will be ethyl and 2 will be dimethyl. So 1 plus 2 plus 2. Here I'm getting the sum as 4, here at 5. Well, always we'll go for the sum locant, sum should be less, smallest. So that's fine. Next question, number D. Number D. The hydrocarbon with 7 carbon atoms containing a neopentyl and vinyl group is which one? Neopentyl, and it should contain neopentyl also, and it should contain a vinyl group also. Vinyl is double bond. One double bond will be there. Vinylic and allylic. Rohan have an answer. 10 maybe C. Try to draw the structure. Isopropyl 2-butene, according to him. Shivam Gupta says B. Rohan says B. Komal says B. So if I'm trying to draw the structure of B, 4,4-dimethyl pentene. So we have CH3, C, CH2. First I'll draw this CH2, CH2, CH3. So this is what we do. 1, 2, 3, 4, 5. Yeah, so correct. B is correct. Because you see here, this is what is a neo group. This is which group? This is neopentyl, and this is what vinyl. You add both of them, this is what you'll get. 4-dimethyl pentene. Very good. Everyone who have got the answer is B. Okay. Very good. Next is alene. If you don't know how to find out sp and sp3, if you have all sigma bonds, it's sp3. If you have one If you have 1 pi, that is sp2. If you have 2 pi, that is sp. Eleven answer is B. Ritik have an answer. 11 answer is B. You can get a question based on this as this also. If percentage S character is more, then electronegativity is more. If your percentage X character is high, so this will be more, most electronegative than this, because your percentage S character here is 50%. Here it is 33.3%, and here it is 35%. So one answer I have of Ritik. I'm waiting for others to answer. Aline C3H4. So C3 and H4. It is only possible when I have two double bonds. So this is what is double bond. If I'm seeing here, this will be 1 pi. So sp2, 2 pi sp, 3 pi sp2. So all are getting S11B. So I have SP and SP2. So B, yeah, correct. Okay, right. Next, number 12. Number 12. B is correct for 11. Sunil, you have given answer for 12th one or 11th one? 12th one, okay. 12th is 12 CH3. So 1, 2, 3, 4, 5, 6. So 3 ethyl, 1, 4 methyl hexane. 3 ethyl, 1, 4. The answer is 12. All the options of 12 are not visible. The first option, I'll write the option here. 3. The first option is 3 methyl, 3 ethyl hexane. The first. The second one is 3 ethyl, 4 methyl, 4 methyl hexane. Option number 3 is 3, 4 ethyl, methyl, methyl hexane. And number 4 is 4 ethyl, 3 methyl, 4 ethyl, 3 methyl hexane. So answer should be I'm doing numbering longest chain. 1, 2, 3, 4, 5, 6. So 3 ethyl, 4 methyl hexane. 3 ethyl, 4 methyl hexane. Number B. 3, 4, 4 ethyl. No, 4 ethyl is not possible. You have to give. You have to see the number part because see ethyl is bigger compared to methyl. So I have to give ethyl smallest number compared to methyl. The option for that will be 12th B. 3 ethyl, 4 methyl hexane. Okay. Let's get to the next one. IUPAC name for the compound. This one. Go ahead. 14 answer name is D. Agnes, right? Correct. Epoxy group. Okay, this is epoxy group. This one is epoxy group. Number will be 1, 2, 3. So 1, 2 epoxy propane. Right. Okay, I have many. So 17, 18, 19, 20, 21. Start with 17. The IUPAC name of neopentane is IUPAC name for neopentane is. That's easy. 17A, 17A, 17A. Yeah, A is answer. That is okay. We'll not. We'll go to next group, number 18. Right. Neopentane. No one has problem, right? 1, 2, 3. How we draw that? This is in this way, right? 1, 2, 3. Here, C. So on 2, 2 we have dimethyl, and the main chain we have propane. So number 1, 18. Go to 18. 18 is A. Komal said B. No, Komal, A. COH is given first priority. According to the new IUPAC lag, COH is supposed to be first. Some book says it as SO3H, but according to what the reputed exams and all have been given, COOH is first and then SO3H. So the answer is A for 18 as well. Number 19. Number 19. 19, Avinash says A. Number 19, Avinash says. Yeah, Rohan, this all is directly, that's why I moved fast. All the things I'm moving slow. For 19, again, I'm giving you time. You can try. This is direct questions. This one is direct order, and this is easy because this was like this. Okay. For 19th, again, you can try. Give you some time. Okay, so Rohan answer A. So everyone have answer as A. Okay, so A is the correct answer for 19. Go to number 20. So we'll have answer for 20. Mm-hmm, mm-hmm, mm-hmm. 20 answer cannot be C. Avinash says A, Rohan says A. So it have to be, this should come here. So 1, 2, 3, 3 from A. 20 answer is A. Correct, Komal right, Sunil right. Next, 21. 21, Ritik have answer A, Avinash have A. 21. 21 is 1, 2, 3, 3 dimethyl cyclohexanol. 21 answer is A. 21 answer is A. And 20 is number of mean not necessary. The number of 20. No, we are counting the, because it's in 1, so that's why we are not counting. In case of 1, you can leave. When you have 1, you can write also 1. If it's not there, you don't have to write. Both the ways it is fine. Anywhere when the number 1 is there, both the ways are fine. Number 1, 21 is A. The 121 is A. Numbering starts from here. Functional group 1, 2, 3. On 3, 3 we have 2 methyl groups, so 3, 3 dimethyl. And at 1 we have cyclohexanol. If 1 is there, I can't, and I see if in the option they have written you directly as cyclohexanol, that also is fine. Okay. Okay. We have 4, 9, 24. Number 24. Twenty-four answer is C. Okay, 24 answer is C, right? 24 answer is C. Next, 25. 25, I have one answer. C. Okay, so the answer is C. Majority wins. 26. In which of the following species is the underlying carbon having sp3 hybridization? Rowan currency. All of you who have got C is right answer. For 25, go to 26. 26 answer I have. Avinash have given it as B. sp3 hybridization. Sunil B. Simple logic. There is no double bond. No double bond means what? It's a sp3 hybridized carbon. So 26 answer is, here we have double bond, here we have double bond, carbonyl compound, here also double bond. Okay, so B.
Excuse me, sir.
B.
Sir, I want to ask something.
Yeah, please.
Sir, will the question of complex exam will be as like the level of Jain?
Sorry, which are there for?
I want to ask, sir, will the question of complex exam will be of the level Jain? Means the level of complex exam question and of Jain will be same.
Yeah. This will be the level of questions.
Okay, thank you, sir.
Okay, I have this question is positional isomer number 33. Number 33. Which of the following pairs of compounds are positional isomer? Positional isomer means position change. Avinash, so they'll get telling me. Okay. 13A answer position isomer. Position of this is changing. First it was on 2, then it is 3. So 2 pentanone, 3 pentanone. So A is the right answer. So A is the right answer. we have done whatever things. We'll just try to mix up the things now, whatever we have done for the chemistry. This is a last class on chemistry. We'll have few more classes on physics is there. So we'll just mix up whatever theory we have done. Random questions we'll try to do. Let's see how much ever we can. Okay, so the first question is, we have pentane, pent, 2-ene, and 4-ine. The question is, you have, this is a question, in pent 2, 4-ene, 1 pent, 2-ene, 4-ine, you have to find out number of sigma bonds and pi bonds. Number of sigma bonds and pi bonds. Number of sigma bonds and pi bonds. Ten sigma 3 pi. Rohan is right. 10 sigma 3 pi. So next question, they are asking, we'll do one more question based on sp2. So we have, this is the structure, CH3, C, CH3, CH3. This is CH, double bond, CH, CH, CH3, C, CH3C, double bond, CH. Now that's in carbon. This is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this carbon is not satisfied, right? So 1, 2, and 3 here. Okay, so this is what is the structure. They're asking you hybridization of the carbon C2, C3, C5, and C6. Hybridization of carbon C2, C3, C5, C6. Now that depends on you which you are taking as 1, 2, 3, which one you are taking 4, 6. It depends on you. sp3, C2 is sp3, sp2, sp3, sp. C2 is which one? sp, sp3, sp2, sp3. 1, 2, 3, 4, 5, 6, 7. C2 is sp, right? C3 is sp3, right? C4 is sp2. C5 is sp2, correct? C6 is sp3. Whose answer is sp, sp3, sp2? Yeah, okay. So Sunil is right. Sunil is right. Right. Let's go to the next questions. We'll do 1, 2 questions on IUPAC, and again we'll try to do questions for the things which we have already done. Time permits. Okay, let's see. The first question is,
Sir, in the previous question, sir, we should
yeah.
give first priority to double bond or triple bond.
No, when you have double bond at, or you have the end carbon, right? In the end, if you have multiple bonds, so irrespective of this thing, we have to give the number as the lowest number. If you have the things are at the last, at the end, that time you don't have to think about the priority order. Whichever will be the end will get the lowest number, because double bond, triple bond was at end, double bond was in middle. So we went for the triple bond, because if you are starting from the middle, then we'll not get the longest chain. You have to focus more on the longest chain. The very first rule says it, you have to go for the longest chain, in which you can try to have most number of multiple bonds. So in that chain, we are able to have most number of multiple bonds, and it will be longest chain as well. That's why we have numbered it from the triple bond.
Okay, sir, I understood.
The question is this. So you need to find out the IUPAC name for this. When is our exam? Rohan, we don't have the update still about the exam. When is your exam? Because what we have scheduled, your timetable is, it is finishing on 24th, your all syllabus. And then if the time is there, we have planned revision session for you, which will be purely based on questions. So depends. Still, we haven't have any information about this exam date. As soon as it will be there, the information will be given to you. When the thing started, we were knowing that it is supposed to be end of the August. So still the end of August is not there. So we still are not sure about the date. Okay, number 11. Number 11. Methyl 3-oxo X 4E. This is one aldehyde group, and we have ketone group. Both is there. So see, when both is there, obviously this will be given the priority. This will be 1, 2, 3, 4, 5, and 6. So 3 number, we can't write it. So we'll try to keep this as the last. We can't have ketone group as the last. So we'll keep CHO in the last. So I'll have what? 3 keto at last alphenol. Okay, so 3 keto. The name I think should be methyl X 4 phenol. 3 keto, 2 methyl X on 4 we have E and all. Okay. So according to me, this should be the answer. Okay. We'll try to revise few. Yes, yes.
Sir, can we write oxo also to keto, no?
Yes. 3 oxo, 2 methyl hex 4 enol is fine.
No, sir, if we will write oxo, then 2 methyl will come first, then at second it will come.
No. No, this will be 3 oxo. So you're saying that in the terms of number, yes.
Yes,
methyl will
then
come first and then
alphabetic order, yeah.
yes, yes. Correct.
Thank you.
Right. So we'll do a few questions related to this. The question is, we have 4D. We have done theories on all this already. Let's try to do question 4D, 5P. We have done few questions as well, if I remember. 5F, 6P. You need to arrange them in decreasing energy order. In decreasing energy order. We'll try to do it faster so that we can cover few questions. These all are good questions that have been already come into some exams. Need to arrange them in the decreasing order of this thing, energy. N plus L rule. When we are talking about N plus L rule, here N plus will be how much? 4 plus 2. Here will be how much? 5 plus 1. Here it will be how much? 5 plus 3. Here it will be how much? 6 plus 1. So the number here is how much? 6, 6, 8, and 8. So see, first of all, which will be lowest will have less energy. Now because this and this is 2 same, that time we have to see the order of n. So here this is 4. So last will be 4D. More than 4D. So 4D will be the least. After 4D, it will be 5P. Then again for 8, smaller number is 5F. So 5F, highest will be 6P. check this n plus L rule first. When n plus L rule becomes same, then we have to see the lesser number of n. Whose n will be less, that person's energy or that orbiter's energy will be less. Important question, important concept. Okay, I have written the order here. Because here n plus n becomes same, I have to check about whose n is less. This n is less, so this will come first. So 4D first, then 5P. Next, again, this number became same here, 8 and 8. Whose n is less, so here this n is less. That will come first. Next this. Okay, I hope you got this. Okay, whoever out there, you can copy down. Next question is very good question. They are telling you to find out that particular orbital which have three angular nodes, that particular, you have to take that particular option which have three angular nodes and three total nodes. Nodes is that place, according to the definition, node is that place where the probability of finding out an electron is 0. So among this four options, which you have the nodes, total nodes is this thing. Okay. If you don't know the formula, you can write the formula as well. So I'll write it here. Number of spherical nodes. You say it as spherical nodes, you say, or you say spherical nodes are also set as radial nodes. So for radial nodes and spherical nodes, the formula is written as n minus L minus 1, n minus L minus 1. And when I'm talking about planar, so there is planar, a planar also the name is angular. So the planar, the name is also angular. For that, the value is equal to L. When you add this total, you will get it as n minus 1, which will be the total number. So to find out spherical or radial nodes, the formula is n minus L minus 1. For finding out planar or angular nodes, it is L. So they're asking you which among these four orbitals will have three angular nodes and three total nodes. Three angular nodes and three total nodes. Answer is C. We have answer as C. 4F. Avinash have given answer as C. Okay. C answer will be right because for this n is equal to 4. For F, the value for L will be how much? 3. So you can see that if I'm writing this, we need to get n value will be 4, F value, L value will be 3. So angular nodes is 3, and if you're writing total nodes, it will be how much? 4 minus n minus 1. So 4 minus 1 is 3. So you can see that answer is 4F. Please write down this formula if you have not written, if it is not known to you. If you know it, very good. You're just practicing. While practicing, if you find any extra concept, you should just write it down. I'll give you the next question. The next question is, how many electrons can fit in? How many electrons? So can you explain it once again? Yeah, sure. See, the question said here is that this is the formula for spherical and angular nodes. So what they are saying is, which among them, these options have the three angular nodes in this thing. So which can take on one options, all the options together. So if I have number 1 is there, number 1A for 5P, if I'm writing n value is 5, L value is equal to 1. So if I'm writing for I'll just write it as SR. SR basically is spherical and radial. Planar and angular is PA. And total, I'll keep it as this. So if you are trying to find out SR is n minus L minus 1. So n minus L minus 1. This is L. And total is n minus L minus 1. This will be how much? 5 minus 2, that is 3. Total will be how much? Total value is equal to n minus 1. So n is how much? 5. 5 minus 1, that is equal to 4. So that's why first option is not this. For second option, N value is 3. For D, L value is 2. So for again SR, if I'm writing, SR will be how much? 3 minus 2 minus 1. So 0. I'm writing PA, that is equal to L. So that is equal to 2. Total, if I'm trying to write, it is N minus 1. So N is 3, 2 minus, so 2. It's normal is you just add it also. 3 and 1 is 4, 2, 0 and 2 is 2. For number C, if you try, N is equal to 4 and LF is equal to 3. Okay, so if I'm writing S and R value, it will be what? 4 N minus L minus N minus L minus 1. That will be how much? 0. If I'm writing angular notes or planar notes, it will be equal to L value, that is 3. 0 plus 3 is 3, that is total. So they were asking me the question which have 3 angular nodes and 3 total nodes. So 3 angular nodes, 3 total nodes. That's why I went with the. Okay. So let's see the next question. How many electrons? The question is, I'm not writing all the questions, so just here. How many electrons can fit in an orbiter with n is equal to 3 and L is equal to 1? See, don't rush. Many people can do mistake in this. I'm just writing the option. Think and do it. N is 3, L is equal to 1. So how many electrons can fit in the orbital for which N is equal to 3, L is equal to 1? Rohan says, see, I said, Rohan, don't rush. Think, man, think. You said me to go slow. You are only rushing now. Okay. Anyway, Rohan, answer is right. It's just kidding. So don't worry. If in the same question I said what is say in the same question what I'll do is I'll change one thing in this. What I'll change in this is I'll specify you n is equal to 1 and in the same question I say I add one line is m is equal to, I didn't give you this is not given. Okay. M value is given as I haven't given you m value also. I just gave you this. I gave you n value and I have given you S value is or ms value, the spin value is plus half. Then how many electron? Options are not there. You just try this. If I'm saying n is equal to 3, I am not given you L value, I'm not given you M value. I'm just telling you to find out S plus half. So how many electrons will be there? Okay. Rohan says 1. Rohan says when I'm saying n is equal to 3, that means L value will be equal to what? L value will be 0, 1 and 2 because L value goes up to where? N minus 1. And when I'm saying L value, so M value will be equal to what? Minus L to plus L. So for all this case, if I'm writing this, no, so here L is not 0. If they have not mentioned you L and M value, you have to see that for 3 L value can be 0, 1, 2. So for 0, if I'm writing for 0, I can have only one orbital. So in that I can have only one with plus half. When I'm talking about 1 now, so when 1 is there, for that 1 again I have 3 options. I have minus 1, then 0, then plus 1. And for 2 again I have how many options? 1, 2, 3, 4, 5. Minus 2, minus 1, 0, 1, 2. So I have to be very, very thorough with this thing. Now see, in 0, 1, I'll have 1 plus half. Now here I'll have 1 plus half. Here I have plus half. Here 1 will be plus half. Again here plus half. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 such electron will be there. Okay, yeah, good. I just see they can play with the questions. That's why I'm just trying to give you that questions which can be. Okay. Okay. Now, so the next question is they're asking you maximum number of electrons that can be associated with this maximum number of electrons that can be associated with this thing. Maximum number of electrons that can be associated with when n is equal to 3, L is equal to 1, and M is equal to -1. Maximum number of electrons that can be associated with following set of quantum numbers where n is equal to 3, L is equal to 1, M is equal to -1. Correct, 2. Because I specified here M -1. That means I'm talking about only one orbital. Avinash, Sujan, correct. If think that this is not there, then how many electrons? N is equal to 3, L is equal to 1. How many electrons? 6. Sujan, correct, right, good. Okay. So I have few things. I have n value, L value, M value, and S value. So where n is 3, 0, 0 plus half, 2, 2, 1 plus half, plus half. Sorry, we'll take this as minus. Take this as minus half. So plus half, or I will take this plus half. 300 plus half, 300 plus half, 221 plus half, 221 plus half, then 4, 3 minus 2 minus half. Then number 4 will take it as 1, 0 minus 1 minus half, and then we can take 3, 2, 3 plus half. Okay. So what this is the following set of quantum numbers. Say they're saying which of the following sets of quantum number is not possible. Which among them is not possible? So this is which one is not possible. This is A, B, C, D, and E, which are not possible. Avinash says D, Sujin says D. Only D, all others are possible. Multiple options are there, right? And this, so check all of them. Okay, I'll give you the options also. They're saying that's giving you the options, the number one option. So in the number one, they have said, okay, I'll just write it as 1 minute. Maybe if I write options, it will be more helpful. This one is say 1, this one is 2, this one is 3, this one is 4, this one is 5. So option 1 is 1, 2, 3, 4. Option B is 2, 4, 5. Option C is 1, 3. Option 4 is 2, 3, 4. So now which one is right? Option A, B, C, D. Which one is right? Oh, I helped you with the options. Now you can try the options. So Neil, Rohan, B, because 5 is only possible. Okay. This is possible, right? N value can be, this is there, this is possible. If it is 2 there, this cannot be possible because it have to be equal to n minus 1. So I'll not check further. If this is there, this is fine. N minus 1 is possible. For this minus 2, I can get it as minus 3 minus 2. Because value here will be what? Minus L to plus L. So this is okay. If this is 1, this is 0, this is fine. But for 0, we can't have minus 1. So which one is not possible? This is not possible. This is not possible. 3, 2, 3. This also should not be possible. The second, 4 and 5 is not possible. Which option is B? Okay. Okay. So this is mistake. Okay. Fine. So this is from my side for today. We'll meet again for physics tomorrow. We'll see how much time is left further where we can revise more and more questions. So thanks for today. We'll see you tomorrow.
Thank you, sir.
Welcome.